going to be predicting redox reactions. So when you have a reaction, you have oxidizing agent and reducing agent. Okay. What is the reducing agent? A substance that loses or give up electron to another substance is a redox reaction reagent. Oxidation agent is a substance that gain or remove the electron from the other. Make sure you don't confuse yourself with oxidation. Is when something is oxidizing is give off electron, right? But when the agent, it make another to give off electron. So this is an example. So you have MgO going to Mg. What happened to Mg? Mg here is 0 here. And it go to the +2, right? It's losing 2 electrons, and it's losing electron. Losing electron means oxidation happens. Something is caused by oxidation, so we need oxidizing agent beside that to make it happen. So here is some oxidizing agent from the restaurant. Ag is stronger than Cu. Cu is stronger than Pb, so Pb is stronger than. So this is the order of that. So from the top to bottom, Ag is the strongest oxidizing agent. And here on the bottom, so it's reducing agent, and is going to be strongest reducing agent. From top to bottom is decreasing. Here from bottom to top is increasing. Here's from top to bottom is decreasing. So spontaneity rules. If the oxidizing agent is above the reduction agent, the reaction going to be spontaneous. If the oxidizing agent is below the reduction agent, it's non-spontaneous. So look at this question. 3 reactions among indium, cobalt, palladium, and copper were investigated. The reaction equation below indicate that 2 spontaneous reactions occurred. These first 2 spontaneous, and only 1 combination didn't react. So this one. Use this equation, construct a redox table of half reaction equation showing the relative strength of oxidizing and reducing agents. So here is oxidizing agent, this is the reducing agent. Since this is happening spontaneously, so oxidizing agent should be above the reducing. So it means cobalt is above indium. Also, this is happening, it means oxidizing agent is Cu should be above reduction agent CO. If this is not happening, means PD should be above Cu, so this should be above that. And I know from the before, Cu is above CO, and you know from here, CO is above indium, so this is the half reaction. So PD, which is that one, should be the top, right? And you have this PD, make sure the PD is there, because whatever is there should be that. The PD is here. And after that, you have to put Cu2 plus. And after that, you have to write for CO. And after that, you have to write for CO2 plus, which actually is there. And then the last thing is you just writing for indium. So from the top is the strongest oxidizing agent here. Here is strong reducing agent is here. Predicting redox reaction in solution. So when you have a solution, you just need to list all elements you have. So in this example, you have a copper metal is placed into acidic potassium permanganate. So copper metal, you know, is Cu. Potassium acidic. When you said acidic, means you have H plus ion. Potassium permanganate. So the potassium is K plus, permanganate is MnO4. Of course, because this is aqueous solution, you have water, H2O. So this is what you have. So what you need to do, first we need to choose the strongest oxidizing agent present in your mixture by starting at the top left corner of the redox table and going down the list until you find the oxidizing agent that is in your mixture. So I have to go to the appendix. So this is the appendix 11, C11 on the top. So this is SOR. So the strongest oxidation agent is here. From the top, you start go to bottom to find that. And from the left is your reduction agent. The strongest one going to be on the bottom that you have to look from the bottom to the top for that. So anyway, I'm going here again to the elements that I have is Cu. So Cu, the table, if you look at the Cu there, do we have so Cu, this is the Cu plus. I'm looking for the pure Cu, maybe. See, we don't have Cu here. We just have a Cu at this side. That it means this is going to be just a reduction agent or Ra. So this one is Ra. K plus, if you look at the K plus, is here. So this is oxidation agent or OA. You don't find the K plus at this side, so it's just OA. And MnO4, see it coming with hydrogen. So MnO4 gonna be your OA oxidation agent. Also H plus, these two can come together. That's why you see these two lines. Or they can come along like that. This H plus, again, is gonna be oxidation agent, it's OA. And H2O, water, you can find it at this side. Let me just find it out. This is H2O here. Also, you can find it at the other side. H2O, where is that? Here is H2O. Okay. So now here is a question. Suppose the solution potassium permanganate, this is that we investigate, poured into the acidic iron 2 sulfate solution. Iron 2, so iron 2 is Fe2 plus, sulfate is SO4. So Fe2 plus, if you look at that, you find Fe2 plus is here. Also at the other side, So you can find the Fe2 plus, you can find the Fe2 plus at this side. So it's going to be reducing agent as well as Ra as well. So that's why Fe2 plus is oxidation agent and reducing agent. SO4, going here, here is SO4 for that. So here we have SO4, which is on the oxidation agent. That is coming with the H2O, right? So just going back here. SO4 is coming with the H plus there. Since this is aqueous solution, this is coming with water. That's why you see that this is, I know H2O is oxidation agent and the reduction agent. Anyway, we need to find the strongest one. So from oxidation agent, we have, we just write it down here. We have K, we have MnO4, we have H plus, oxide, we have Fe, and SO4, SO4 2 negative, and we have H2O. This is our OA, and our RA is Fe2 plus, RA here is H2O, H2O. To find a strongest OA, I'm gonna look here. From here, see, from the top is the strongest. So I come down until I find the strongest. So here I don't get that, I don't get that. Here is MnO4, right? This is what I have. So it's gonna be the strongest one. So SOA is this strongest. And also for this one, I come down and I got to H2O. I don't get Fe2 plus, so this will be my strongest reducing agent, SRA. See, MnO4 is your SOA, and okay, so let me just back and correct myself. I don't look from the top here. What I do, I have to look from the bottom because this is decreasing from the top to, from bottom to the top, decreasing means the strongest is here. Okay, look at that. We are Fe. I missed it. Let me just go back. So if Fe2 plus is here, and if you compare it to the H2O, the Fe is stronger, Fe2 plus, which is there, is coming first. compared to the H2O, which is there, right? So I'm comparing these two. Of course, the strongest now gonna be your Fe. Correct that. So this is Fe. This is the strongest reduction agent. Now, you're there. So you just, you find your stronger SRA and SOA. So you use these two. MnO4, which is your strongest, then we found it here. You write that reaction. And do the same thing, you do it for Fe2 positive, this one. You write both. Make sure for the second one, you writing that from left. I'm sorry, right to left, because this is for your reducing agent. So we're writing that, and now I have to multiply this one by 5 because I need to balance the electron. I multiply this by 5 and I add both sides, so electrons cancel, and this is what I have. Now I want to see if this is spontaneous or not. Just need to look at my oxidation and reducing. So it's MnO4 comparing to Fe2 plus. MnO4 comparing to Fe2 plus. It's going here. MnO4 is here and Fe2 plus there. Therefore, this is above that. So this is gonna be spontaneous. Then if that was reverse, it would be non-spontaneous. This is a spontaneous reaction, SPONT. Okay, here is another example. In a chemical industry, could copper pipe used to transport a hydrochloric acid solution? So here, copper is Cu. Hydrochloric solution is HCl. We have H positive and Cl. Also, this is an aqueous solution. We have H2O. Now, let me just erase this, what we have. If you look at the table, you will find a Cu on the reducing agent. So this is the reducing agent, Cu. Cu is the reducing, and H plus here will be your oxidizing agent. And the Cl negative, here I will find it. Cl negative, so here is Cl negative, but I wanted to have that there. It's going to be your reducing agent. And this coming with water, as you find it, this is Cl is coming with water. That's why you just have a line here. Also, H2O, you know, is oxidation and reagent. So overall, what we have, it's for Ra. For Ra, we have Cu, we have Cl negative, we have H2O. These are my Ra. And oxidation agent is H plus and H2O. So let's just look at oxidation agent first, see which one is the strongest. So from the top, if you go to the bottom, so you have, looking at this, you have this H plus, but do you have H2O above that? So I'm gonna find H2O to make sure. This is H plus, and here is H2. Of course, the H plus is above that. So it's going to be the strongest SOA. Now for reducing agent, I need to look from down here and find it out. Here you just go up. So here is CU. So we got CU first. And just to make sure, I know Cl negative on the top. And H2O should be somewhere. H2O is here. So this is the Cu will come first from the bottom. So strongest. So this is a strongest reducing agent. So Cu is strongest reducing agent. Therefore, this is the strongest reducing agent, Cu. You just write the half reduction for Cu and H. Then the electrons are balanced. So you just add the right and left. I need to take care of the spontaneity. So it's H plus and Cu. So looking at here, H plus is there and Cu is there. CH plus is here and Cu is here. So this is down respect to that. So it's non-spontaneous. Should be on the top respect to this one to be spontaneously. This is a non-spontaneous reaction. What does it mean? It could be possible to use the copper pipe to carry hydrochloric acid. It means because it's not happening, this reaction not happening, the pipe and the copper and this hydrochloric acid will not react. So it's possible to transfer